students, and welcome to the lesson on differentiability. And first we're going to take a look at sort of the original problem in calculus, which is the tangent problem. And it asks us to find the slope of the tangent line to a curve. And I realize that's not great English there, so let's illustrate this with a example. So let's say you have something like this, which looks like a parabola, and we want to know the tangent line is the line that just grazes a single point on the curve, and we want to know what's the slope of that line. All right. Now, one thing that makes this difficult is we only have 1 point. In order to find the slope, we typically need 2 points. So we want to use what's called a secant line, which is a line through 2 points. All right, so we make a point here, take another point here, and draw a line through that. And then what we generally want to do is take this point and move it closer and closer, this blue dot here, and move it closer and closer to the green dot. Okay? So the slope of the blue line here is, of course, change in y over change in x. Right? That's the traditional definition. Now for the tangent line, we're not able to do that because we only have 1 point. So what we typically do in order to find the tangent line is take the limit. So we take the limit as delta x approaches 0 of f of x plus delta x minus f of x, all of this over delta x. Okay? So in other words, we put another point out here and we move it closer and closer to this green point, or we move this blue dot here closer and closer to the green dot until they merge onto 1. Okay? And this is the way that we can find the tangent line. Okay? Now there is something very profound in all of this, and that's that you're finding the slope using only 1 point. Okay? So we're finding a slope using only 1 point. Okay? And this is kind of a difficult problem that has baffled mathematicians for quite a long time, until Newton and Leibniz and some other mathematicians in the 1600s and 1700s were able to tackle this problem. Okay? And I went over this a little bit quickly because this is really a concept that's been covered in pre-calculus. If you have any struggles with that, please check with your teacher. We're going to move on next to the derivative and what the derivative really is. Definition of the derivative of the function f at x is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Okay, so I'm going to box in this formal definition and then give you kind of an intuition about why this is true. So say we have some sort of curve again, and we want to find the derivative at the rate of change at this point, or the slope of the tangent line at this point. So what we do is, let's say this point here is x. Okay? What we do is we pick some other point on here, and this length here is called delta x. Okay? And we draw a secant line through there, and then we move this blue line, this blue dot closer and closer. In other words, shrinking delta x until it becomes 0. So this point here is f of x plus delta x, and this point here is, of course, f of x. Okay? So essentially what we're doing is we're saying the difference between these two, the height of these 2 points, is the change in y. The difference between x and x plus delta x is the change in x, and we're moving delta x, we're shrinking it down slowly until this point here merges onto this one. Okay? And then what we have is the same situation as a tangent problem above. Okay? That's the formal definition of the derivative. Now, with that, there's a couple different forms of the derivative as well that we can look at. And this form that we have right now, this is really the derivative for the entire function. We can also find the derivative at a specific point. Let's call it C. And so this is called f prime of C is equal to the limit as x approaches C of f of x minus f of C, all divided by x minus C. Okay. So here's another way we can look at the derivative. And all this really is saying is that if we just call, let me get another color here, but if we just call this point here C. Okay. So all it's saying is as x approaches C, that's the same thing as the delta x approaching 0. Okay. So this is just another way of saying the same thing. Oh, sorry, I didn't mean to call this C. I meant to call, maybe we have another point back here called C. All right, and we do the same thing, but instead of moving the dot, the blue dot in front, we can also do the same thing by moving the red dot so that it's closer and closer to the green one. So we can call this point here C. So instead of finding the derivative using a point that's to the right of the point that we want, we can also find it as it is to the left of it. All right? So this is just another way of using called an alternative form of the derivative, and in some cases it might be easier to find the derivative this way than in the other form. Now, calculus was discovered simultaneously by a couple of different mathematicians, and they came up with their own notations for it, and also there's some other notations that's been introduced over the year, so it's good to be familiar with all of this. So there's different ways that we can make a notation for the derivative. This is one way to say it. All right, this is pronounced f prime of x. Okay. Another way we can say it is dy over dx. So this is basically saying change in y with respect to x. Here's another way to say it. We can sometimes say d over dx of some function. Okay. And then finally, this is a little bit more rare, but you will still see it. You'll see a d and then x and then y. And what this is saying is that x is the independent variable, and that y is the dependent variable. Okay? And these other notations are actually quite good in some cases because they allow us to decide what is the variable in this case. Okay? Because if that's the case, then we treat that letter as the variable and everything else in there as a constant. Alright, so we'll end this video here, and we'll pick up in another video where we talk about differentiability, whether or not we can even take the derivative, because that's not really true at all cases. Okay? But the main ideas here are the tangent problem, what a derivative is, and the traditional ways and some other ways of writing a derivative.